Good morning, class 11. Today, our topic of discussion is that our so called gravitation chapter. Now, up to Friday, my online class, we have completed still escape velocity and those things. So, today I am going for completely a different topic, and that is, in other terms, interesting also. That is all about the satellites. Satellite means basically here we are dealing with that artificial satellite, means where which one who is placed by human being, by spacecraft or spaceship. They are placing it on the orbits of earth, either in the equatorial plane or that polar plane. So first I am going for, basically we are going to discuss two type of satellite. One is geostationary satellite, another is polar satellite. Now what is geostationary satellite? Basically geostationary satellite is a artificial satellite which just placed on the equatorial plane. This one is the equatorial plane. Can you see? That is from east to west or west to east, what you can say. So this one is the equatorial plane. In this equatorial plane the geostationary satellite placed. Why it is called geostationary, I will later on explain. So in the same sense as the earth with the same period of revolution as that of the earth about its own axis, it rotates. Means basically it takes 24 hours to complete a rotation. Clear? So this is called geostationary satellite, and this orbit is called parking orbit. See here I had shown you few geostationary satellite, that is like Meteor, and one is from Russian Federation, another for USA. Here probably India's geostationary satellite not given, so India also has geostationary satellite. This geostationary satellite was placed by that Japan. So these are the geostationary satellite. Why? What is basically geostationary satellite? A geostationary satellite is a earth orbiting satellite. It is moving just on the equatorial plane of the earth. Where it does placed, it is an altitude approximately 35800, that is basically nearly 23 miles directly over the equator, that revolves in the same direction of the earth rotate. That I said just now. At this altitude one orbit takes 24 hours, the same length of at the earth requires to rotate once in its own axis. The term geostationary, why this term came? The fact is the satellite appears nearly stationary. Why? Let's see the next slide. See, suppose here is my satellite and you are here, staying here. So as you are moving with the earth, the orbit satellite also parallelly moves with you. So what you will see? You will see every time the satellite watching you or you are watching the satellite, means it remains stationary, but it's not actually stationary. It is moving parallelly with you and you are moving with the attachment with the earth. I repeat, as you are staying here, suppose at this arrow, so as earth move you are also moving with the earth. Now at the same time suppose this satellite also moving with the earth orbit, so this distance is parallel now, your distance and the earth satellite distance. So what is happening, that satellite remains stationary. So that's why it is named as that geostationary satellite. So geostationary satellite, that what it is basically stationary with respect to the observer. Observer means suppose I stays there, so that is that observer that is remains stationary. Began the new global mobile communication network uses geostationary satellite. So this is the structure of geostationary satellite. Our earth is surrounded by so many geostationary satellites. Why? I will explain later on. Now how geostationary satellite placed on the orbit. A geostationary satellite carries with it solid fuel rocket engine to provide the necessary kick at the epoch of the satellite transfer orbit. Why it is called apogee? Apogee means the satellite transfer orbit. Okay, circular equatorial orbit with the essential zero inclination. Why I need zero inclination? Because if it is inclined a little bit, because here if it is inclined a little bit, it is not parallel with the equatorial plane with the earth, That's why they are specific about the zero inclination. So that is what geostationary satellite. What are the important points I need to remember for geostationary satellite? That are, first of all, it should revolve in an orbit concentric and coplanar equatorial plane. Why? Let's see the diagram again. This one what? Elliptical orbit, or rather I can say circular orbit. So this one is the concentric equatorial plane. Clear? So that's why it is the first point in geostationary satellite. Its sense of rotation should be same as that of Earth about its own axis, that is in anti-clockwise direction from west to east. Okay, that's already stated. Its period of revolution around the earth should be same that of the earth about its own axis, that is 24 hour. Clear? So this is that 2 pi root under r3 by gm. This is came from that escape velocity part what I had discussed in online classes. So if I calculate the time period of revolution, that will be nearly 24 hour. Now, let's see how geostationary satellite helps in telecommunication. See, suppose this is my Earth, so I am having three geostationary satellite. One, two, three. Three geostationary satellite. Three geostationary satellite just forms a triangular wave. So suppose here is my transmitting antenna. So it transmits something that will reflect by this satellite, comes here. So here I will get something. Now when it reflect, at the same time it can perform reflection over the second station. Now from that second station the light reflect here, sorry, information reflects there, and from here the reflection goes on. So like that, the reflection cone of the broadcast surface, this is actually called the reflection cone of the broadcast surface. This is called reflection cone. Also when we will study in class 12, that is communication, this is also called that line of sight or that horizon, radio horizon. This one is called also radio horizon, that transmitting antenna plus receiving antenna, total this distance is called radio horizon. Nowadays we are very much fond of what? Satellite communication. And satellite communication is a thing which is next to impossible without geostationary satellite, because every geostationary satellite who are helping us to in broadcast system are always connected with one another, and through this communication system within a second the information goes from one to another one. That's why it is very fast geostationary satellite, because the information goes on in the forms of light, and it is take nearly 3 into 10 to the power 8 meter per second with the speed. Now coming from the next satellite, that is called polar satellite. Now, before discussing polar satellite, let's discuss what is polar orbit. So, this is what? This is my parking orbit or equatorial orbit of the Earth, and this one from north to south or south to north, this one is called what? Polar orbit. So, obviously, the satellite which placed on the polar orbit is called what? Polar satellite, and the satellite placed on the geostationary orbit or parking orbit are named as geostationary satellite. Clear?